All right, strap in everyone because today we're going deep on some really cool AI research just for you.
That's right, we're diving into the world of large multimodal model.
LMMs catchy.
Right, definitely rolls off the tongue.
But what are they really? Think of them like those super-powered search engines.
Yeah, but ones that can process both text and images to answer questions.
It's like having a research assistant that can, I don't know, analyze a photo and a report at the same time.
Exactly, and they're getting really good at figuring things out,
Okay, so these things are smart, but even they need a little help sometimes.
especially when it comes to really nailing that logic.
And that's where chain of thought prompting comes in.
Right, it's basically giving the model a step-by-step guide to solve a problem,
So we can see how it's actually like thinking.
and that's crucial,
Yeah, understanding the how is super important with AI.
especially if we start using it for, bigger and bigger things.
Absolutely. So researchers created this system called MME-CoT.
Stands for Multimodal Evaluation of Chain of Thought.
Okay, so it's like a giant test.
Yeah, specifically designed to analyze how well LMMs can reason when you give them both text and images.
And this is where things probably get really interesting.
Oh, definitely.
So what did they find? Any surprises?
Tons. Strengths, weaknesses, some real head scratchers too.
Okay, give us the rundown.
So MME-CoT covers 6 different domains.
6.
Math, science, even deciphering text from images. That's OCR.
Oh, wow.
Logic puzzles, figuring out timelines, and analyzing complex scenes.
Wait, so we're showing a model a photo
Right.
and then asking it to do like anything from solve a math problem based on what it sees to figuring out what's happening in a story just from the pictures?
Yeah, you got it.
That's incredible.
And the researchers didn't just stop at, right or wrong answers.
So what did they do?
They broke down the reasoning process into 3 main parts.
Okay, I'm intrigued. What are they?
The quality of the reasoning,
Uh-huh.
how robust that reasoning is,
Okay.
and how efficient the model is at getting to the answer.
All right, let's break those down one by one. What makes for good reasoning in an LMM?
Well, that's where things get a little tricky.
How so?
You see, reasoning quality is all about how logically sound each step the model takes is.
So it could get the right answer?
Right, but the way it got there might not make sense.
Ah, so like those math problems in school where you had to show your work?
Exactly, not just the final number.
Gotcha. So how do they judge that work?
2 key ideas, recall and precision.
Okay, I think I remember those terms from somewhere.
Think of it this way, recall is like remembering all the important details.
So did the model use all the necessary info to answer the question?
Exactly, and precision.
Is about the accuracy of each step.
Yeah, did the model make any logical jumps or use info incorrectly?
So high recall, the model didn't miss anything crucial.
Right.
And high precision means it didn't go off on any illogical tangents.
You got it.
Makes sense. So what did they find?
Here's the surprising part. Even models that got the right answer
Uh-huh.
sometimes had low precision or low recall.
Meaning?
They either made a mistake in their logic somewhere
Oh.
or missed a key piece of info even though they stumbled onto the right answer.
Hold on. If these models are supposed to be so good at reasoning,
Right.
why are they getting tripped up like that? It doesn't seem very intelligent, does it?
It is kind of counterintuitive.
Yeah.
You'd think if they got the answer right, their thinking process would be solid.
Right. Solid.
But that's why we need tools like MME-CoT.
Okay. To really dig into what's going on?
Yep, it's a good reminder that even the most advanced AI still has a long way to go.
Okay, I see your point. So we've got reasoning quality. What about reasoning robustness?
Good question. This one's about consistency.
Okay, so how reliable the model is.
Exactly. Remember all those different tasks MME-CoT covers?
Uh-huh.
They can be split into 2 categories, perception tasks and reasoning tasks.
Perception versus reasoning. Break that down for me.
Okay, so perception is about recognizing and understanding what's in the image at a basic level.
So if you see a photo of a cat, you know it's a cat.
Exactly, that's perception.
Gotcha.
Reasoning is about taking that info and doing something with it, solving a problem, making a connection.
Okay, I see.
It involves multiple steps and some logical thinking.
So seeing the cat is perception.
Right.
But figuring out that the cat is about to pounce on a mouse based on, its posture, that's reasoning.
You nailed it.
Okay, cool.
Now, the researchers wanted to see how this chain of thought prompting affected how well the models did on both these types of tasks.
I'm sensing it wasn't always what they expected.
You're catching on. This is where it gets really interesting.
Hit me with it.
In many cases, chain of thought prompting actually made the models worse at those simple perception tasks.
Wait, what? Really?
It's like making them overthink a super simple question.
So instead of just saying, hey, that's a cat, they're trying to write a whole essay about, the feline species.
Huh. That's a great way to put it.
That's pretty wild, especially if you're relying on these models in real-world situations.
Whole.
You wouldn't want your, self-driving car to overthink, whether it's seeing a stop sign.
To give you a concrete example.
Please.
One model, called Intern VL 2.5-8B,
Okay.
actually performed almost 7% worse on perception tasks when it was given chain of thought prompting.
Oh, wow, that's a lot.
Imagine a doctor missing a key symptom because they're overanalyzing something simple.
Not good.
Not good at all.
Okay, that's a serious red flag. Clearly, this chain of thought thing needs some fine-tuning.
Yeah.
So what about that last part, reasoning efficiency?
This one's about cutting to the chase.
Okay, how so?
We've got these really advanced models, like GPT-4o, that can produce incredibly long chains of thought.
Wow.
But are all those steps really necessary? Or are they just adding noise and confusion?
So it's not just about how deeply the model can think.
Right.
It's also about how smart it is with its thinking time.
You got it.
Cool. How do they measure that?
The researcher came up with two new ways: relevance rate
Okay.
and reflection quality.
Relevance rate, I'm guessing that's about, like, staying focused.
Exactly. Is the model's output actually relevant to the question? Or is it getting sidetracked?
And reflection quality?
That's about the model's ability to, like, double-check its work.
Like saying, hold on, does this really make sense?
Exactly. Reflection quality measures whether those thinking breaks actually lead to a better answer.
Okay, what did they find? Are these models as good at reflecting as, as us humans?
The results were pretty surprising.
How so?
A lot of these long thoughts processes included a bunch of irrelevant information.
So they're getting lost in the weeds.
Yeah, pretty much. And even when they did try to reflect,
Uh-huh.
it didn't always make the answer any better.
So even the best models can get distracted and overthink things, just like us humans. You're telling me they're not these perfect logical machines we thought they were?
It seems not.
This brings up a big question.
It does.
For the future of AI, how do we teach these models to know when to use their deep thinking skills?
Right.
And when to keep it simple?
It's a fascinating question.
It really is. It seems like this MME-CoT benchmark is revealing some fundamental challenges in how we're approaching AI development. It's not just about building bigger, more powerful models.
No.
It's about teaching them to think smarter.
Precisely.
That's incredible. So we've got to wrap up this part of the deep dive.
Yeah, we're just getting started.
But I'm dying to know, how did the different models actually stack up against each other? Who were the star performers? Who struggled?
Well, let's start with the top dogs.
Okay, who were they?
Based on the MME-CoT results,
Uh-huh.
GPT-4o is definitely one of the best, especially when it comes to remembering all the important details.
High recall?
Exactly. Incredibly high recall.
Okay, but was it perfect?
Not quite. Another model, called MME-K1.5, actually beats it on precision.
So it's more careful about making sure each step in its reasoning is accurate?
Yeah, you could say that.
So it's like a trade-off.
Yeah, it is.
GPT-4o is like the student who crams all the information but might make some careless mistakes. While MME-K1.5 is the one who studies carefully and gets every detail right.
That's a great analogy.
I try. What about the open source models?
Oh, there were some interesting results there, too.
Like what?
Well, one model called QVL72B really stands out.
In what way?
It actually outperformed a model that was specifically designed for reasoning.
No way. Which one?
Intern VL 2.578B-NPO, quite a mouthful.
It is. So even within the world of open source models, there's a lot of variation in how well they handle this whole chain of thought reasoning thing.
Exactly, and that's why benchmarks like MME-CoT are so crucial.
Yeah, they give us a way to compare these different models and understand their strengths and weaknesses.
So we can keep pushing the boundaries of AI development.
This whole conversation is making me realize just how complex AI is.
It is.
It's not just about building machines that can, calculate things faster or store more information.
No, it's not.
It's about replicating the very essence of human thought.
You've hit the nail on the head.
And that's a tall order.
It is a tall order.
Wow, so we've covered a ton of ground here.
We have.
This has been a fascinating deep dive so far.
I'm glad you think so.
But this is just the beginning, right?
Oh, absolutely.
There's so much more to explore.
Definitely. We've only scratched the surface.
Okay, so stay tuned.
We'll be back soon with more on MME-CoT and the future of AI reasoning.
And trust me, you don't want to miss it.
It's going to be good. And this is just the tip of the iceberg.
Oh, really?
These findings from MME-CoT, they have some big implications.
For the future of AI.
Yeah, it's like we're peeking into the hood of these models, seeing how they work.
And what are we seeing?
Well, it's exciting, but also kind of unsettling.
Okay, how so? You said even the best models are having trouble reasoning. So what does that mean for, how we actually build AI going forward? Are we on the wrong track?
It definitely points to a shift that needs to happen. It's not just about making models bigger, more complex.
Right, right.
It's about making them think smarter, more efficiently.
So we need to teach them to be more, I don't know, selective.
Yeah, in their reasoning.
Like know when to dive deep, when to take a shortcut.
Exactly.
It's almost like teaching them to think about their own thinking.
You're getting at something really important there.
Am I?
You are. It's like giving them a sense of self-awareness when it comes to problem solving.
So metacognition.
Exactly, that's the term.
We're trying to teach a computer to be self-aware. That seems like a big challenge.
This huge challenge, one of the biggest in AI research right now.
Okay, I can see that. So let's zoom back in on MME-CoT for a second.
Sure.
You mentioned earlier that the researchers were, like, really careful about the data they used to build this benchmark.
Yeah, they were.
What does that actually mean in practice?
They didn't just grab random images and text, throw it at the models, and see what happens.
Okay, so what did they do?
They made sure the data was high quality, diverse, relevant to real-world situations. Remember those 6 domains we talked about? Each one was carefully crafted.
To really challenge the models?
In the right ways, yep.
So it's like instead of feeding them, junk food, they were giving them a carefully balanced diet.
Exactly. A diet designed to boost their brain power.
I love that analogy.
And speaking of ingredients, there's this really cool thing they did.
What's that?
It's called key step annotation.
Key step annotation. What is that?
This is where the human touch comes in.
Oh, interesting.
So for each question in the benchmark,
Yeah.
a team of experts basically broke down the reasoning process.
Into smaller parts?
Yeah, into its core components. They identified the essential steps a human would take to solve the problem.
So it's like giving the models a set of instructions.
Yeah, like a roadmap.
Okay, to follow.
Exactly. These key step annotations, they're like a blueprint
Okay.
for both training and evaluating the models.
So it helps the models learn how to, structure their thinking.
And it allows the researchers to see how closely the model's reasoning matches up with how a human would approach the problem.
That's really clever. It creates a more objective way to measure reasoning ability, which seems pretty important when you're comparing different models.
Absolutely. And this attention to detail with the data, it's one of the things that makes MME-CoT so powerful.
Okay.
It gives us a much more detailed and insightful view into how these models actually reason.
I see. This whole conversation is really making me realize just how complicated AI is.
It is complex.
It's not just about building machines that can calculate things faster or store more information.
No, it's not.
It's about, replicating the essence of human thought.
You've got it.
And that is a tall order.
It is. It really is. AI research is ultimately a quest to understand and replicate intelligence itself.
Whoa, we're getting deep here.
We are, and as we go deeper, we encounter these philosophical questions about consciousness, creativity, what it means to be human.
Wow, I love that this conversation is taking us there. It makes me think about AI in a whole new light.
It's one of the things that makes this field so fascinating.
It really is. Okay, so we've talked about data curation,
Right.
key step annotations.
Uh-huh.
But I'm still curious about the models themselves.
Sure.
You mentioned a few standouts earlier.
I did.
But what makes one model better at reasoning than another? Is it comparing brain sizes?
That's a great question, and there's no easy answer.
Oh, okay.
The way these models are designed, structured, it's incredibly complete.
Layers upon layers.
Exactly. Layers upon layers of artificial neurons, processing information, learning from data.
So trying to understand how these models work is like trying to understand the human brain.
Maybe even more complicated.
Oh, wow. But there must be some general principles, right?
There are.
Like what makes one model a better thinker than another?
Well, one key factor is the size of the model.
Okay, so bigger is better.
To a certain extent, yes.
More parameters, more smarts.
But, as we saw with the MME-CoT results, bigger doesn't always mean smarter.
Right, right.
Sometimes those extra parameters can lead to overthinking, inefficiency.
So it's like having a giant toolbox with every tool imaginable.
Exactly.
But not knowing which one to use for the job.
You nailed it. It's not just about having the tools. It's about knowing how and when to use them effectively.
And that's where things like, training data come in?
Yeah, training data, prompting techniques, innovative designs.
Speaking of innovative designs, you mentioned that some models have this reflection mechanism.
I did.
What's that all about?
This is a really cool development in LMM architecture.
Okay, tell me more.
Remember those reflection steps we talked about?
Where the model pauses, reevaluates its conclusions.
Exactly. Those steps are facilitated by this built-in reflection mechanism.
So it's like hitting the pause button on their thinking process.
Yeah, so they can take a step back.
See the bigger picture.
You got it. And the models with these reflection mechanisms, they tend to do better on reasoning tasks overall.
It's like having a built-in editor for your thoughts.
Exactly. And this is an area where we're seeing a lot of exciting progress.
Researchers are getting better at designing these reflection mechanisms.
They're getting more effective all the time.
This deep dive has been, a wild
It
ride.
has been a lot of information.
We've covered so much, from the basics of LMMs, chain of thought prompting, to the nitty-gritty of data curation, even the inner working of these models.
It's a lot to take in.
I feel like I've gotten a crash course in AI reasoning.
I'm glad. It's a vast and ever-evolving field. There's always more to learn.
So as we wrap up this part of the deep dive,
Yeah.
what are some key takeaways you want our listener to walk away with? What's the big picture here?
Well, first off, MME-CoT is a game changer.
In what way?
It's giving us a whole new level of insight into how these LMMs reason.
Okay.
It's pushing the boundaries of how we evaluate AI
I see.
and forcing us to think critically about how we measure intelligence.
Both artificial and human.
Exactly. We can't just look at how well a model performs on a surface level.
Right.
We need to analyze the actual reasoning process.
We got to dig deeper.
We do, and what MME-CoT is showing us is that even the most advanced LMMs, they still have a lot to learn.
When it comes to reasoning.
Yeah, they can get distracted, overthink simple tasks.
And the reflection mechanisms, while promising,
Right.
they're not perfect.
Not yet. But the progress we're seeing is remarkable.
It really is. Just a few years ago, the idea of an AI that could understand both text and images and reason about them, it was like science fiction.
It was.
And now we have models that are doing just that.
And getting better every day.
It's incredible how quickly this field is moving, but as you said, it's important to be aware of the limitations,
Absolutely.
the challenges.
We need to be both optimistic and cautious.
We need to embrace the potential of these technologies while also being mindful of their ethical implications.
And the need for responsible innovation.
I couldn't agree more. It's a delicate balance, but it's one that we need to strike if we want to harness the power of AI for good.
I completely agree.
All right, so we've gone pretty deep here.
We have.
But this is the deep dive, right? And we can't leave our listener hanging
Absolutely not.
without something to really chew on, you know?
Right, we've given you this glimpse into MME-CoT, how these LMMs reason. But now let's flip things around a bit.
Okay, how so?
Think back to what we've learned.
Okay.
Even the best models, they make mistakes, they get distracted, their logic isn't always perfect.
It's almost like humbling, isn't it?
It is.
Makes you feel a little less bad about forgetting where you put your keys, you know?
Exactly, because we humans, we aren't perfect reasoners either.
That's true. We have biases, blind spots, we jump to conclusions, we overthink things.
All the time.
So if we're using AI as this, model for intelligence,
Yeah.
should we just accept those flaws as part of the deal?
It's a good question.
Or should we be pushing for AI that goes beyond human capabilities, even in those areas where we struggle?
That's the million-dollar question, isn't it? What is the ultimate goal here?
Are we trying to create machines that think exactly like us, flaws and all?
Or are we aiming for something even more advanced?
It's a question with huge implications.
It really is.
If we want AI to help us solve problems, make decisions,
Right.
shouldn't it be better at reasoning than we are?
You would think so. But there's also something to be said for AI that can understand human experiences.
Okay, yeah, even our messy ways of thinking.
Exactly. Maybe that's key to building trust. Yeah.
Trust between humans and machines.
Right. Collaboration.
It's almost like there are different levels of AI intelligence. Maybe for some tasks we need AI that can, I don't know, mimic human reasoning very closely.
Okay.
But for others, we want it to go beyond our limitations.
That's a really interesting way to think about it.
And as those levels evolve,
Right.
these conversations about their impact on society, how we understand ourselves, even the very definition of intelligence, they become even more important.
Absolutely crucial conversations to be having.
This has gone way beyond just a technical deep dive.
It has.
It's philosophical.
It is. It really is. And that's what makes this field so fascinating.
It's not just building machines.
No.
It's about exploring the very nature of thinking, of being intelligent.
What it means to be human.
We've thrown a lot of information at you today.
We have.
But we don't want this to be a one-way street.
No, definitely not.
This whole MME-CoT benchmark, it's out there. It's publicly available.
There's tons of info online about LMMs, chain of thought reasoning, all of it.
Don't let the technical stuff scare you off.
Yeah, there are resources for everybody.
Beginners, experts, everybody.
Who knows? Maybe you'll be inspired to, contribute to this field yourself.
That's what we love about the deep dive. Sparking that curiosity.
Yeah.
Pushing you and explore further.
So, to our listener, we leave you with this.
Okay, hit us with it.
If AI can learn to reason, to reflect, maybe even surpass human intelligence, what does that mean for our future?
What role will we play in a world shaped by these thinking machines?
Big questions to ponder.
It's a future full of possibilities, but also some serious questions we need to grapple with.
For sure.
And that's where this deep dive ends, but your own exploration, that's just beginning.
Keep learning, keep exploring.
Thanks for joining us, everyone. TVCA.